In this video, I'm going to explain how the attitude indicator works and how you can use it for IFR flight. If you're trying to get your instrument or your commercial rating, you're going to want to watch this entire video. Welcome to Free Pilot Training. I'm Josh, and today we're talking about the attitude indicator. During the early days of aviation, pilots would call this instrument an artificial horizon because that's basically what it is. So technically, artificial intelligence has been around for quite a while because pilots who learn how to use this instrument correctly can control an aircraft with extreme precision, even if they're flying in instrument meteorological conditions or IMC. As an IFR pilot, the attitude indicator is the focal point of your instrument cross-check. And if you use the hub and spoke method, this allows you to master control over the aircraft. Now, just like the heading indicator, the attitude indicator is a gyroscopic instrument that should be placed in the center of your six-pack. If it's not in the center, some idiot probably set up your cockpit, and this is just going to make things a little bit trickier for you. Because this, in my opinion, is one of the most critical of your 6 primary flight instruments if you're operating under instrument flight rules. As a quick reminder, the purpose of the attitude indicator is to measure the aircraft's pitch and bank in relation to the horizon. That way you don't have to look outside to know where the sky is and where the dirt is. The attitude indicator is color-coded to make it dummy-proof so you know when you have a bad attitude. That way you can fix it. Keep in mind, there are a lot of different kinds of attitude indicators out there, but all the ones I've ever seen come with some kind of bank index so you can tell what the bank angle of your aircraft is. When your aircraft is in a bank or a roll, the roll pointer or the roll indicator points to the approximate bank angle of your aircraft. In addition to that, this miniature aircraft shows you the bank angle of your wings in relation to the horizon. When the roll pointer is centered on the bank index, the aircraft's bank angle is 0 degrees. But if the roll pointer is aligned with one of these first sets of tick marks, this tells us that our aircraft is in a 10-degree bank turn. Then the second set of tick marks represents 20 degrees. Now this third set of tick marks in both directions represents 30 degrees of bank, and on most attitude indicators you'll notice that these are just a little bit bigger or bolder so you can see them easier. Then we have the 45-degree markings, and these markings show us when we're in a 45-degree bank turn. On a lot of older training aircraft, you'll notice that they don't have 45-degree markers. In this case, you just kind of have to estimate where 45 degrees is. It's right in the middle of the 30 and the 60-degree markers. You really shouldn't be using 45 degrees of bank anyways if you're in IFR conditions, so it's not really a big deal. I personally think they just put them on here for steep turns. And here we have the 60-degree markers, and obviously these tell us when the aircraft is in a 60-degree bank turn. If you use 60 degrees of bank in the weather, you're going to scare the absolute crap out of your instructor, so please don't do that. Next, we have these markers on the horizon. These let you know when you hit 90 degrees of bank. Now, there's a couple things I want to mention here. First, just because the bank index shows that your attitude indicator can reach high bank angles, it doesn't mean that you should be using these. Your airplane might have a bank angle limitation. If it does, you'll find that in the POH. And even if it doesn't, bank angle can increase your load factor exponentially during a level or a climbing turn. So make sure you know your limits before you just start assuming things. The other thing I want to mention is that your airplane might be in a bank, but that doesn't mean it's turning. You'll need to use one of these guys if you want to know that, and we just talked about that in the last lesson. Now let's take a quick look at how the attitude indicator indicates pitch. And to do that, we need to look at something I call the pipper. To determine your aircraft's pitch angle in relation to the horizon, you need to look right here at this little center point on the miniature aircraft. This is what I call the pipper. In this example, the pipper is currently right on the horizon. This tells us that our pitch angle is currently at 0 degrees. But as you can see, there are also markings that can show you when the nose of your aircraft is pitched up or down. Larger graduations like this are placed every 10 degrees, so if my nose is pointed up on this mark, my aircraft is pitched up to a 10 degrees nose-high attitude. These smaller graduations show us every 5 degrees of pitch. If my nose was pitched down to here, I'm currently at 15 degrees nose low. Now, one important thing to note is that if your nose is pitched up or down, that doesn't necessarily mean you're climbing or descending. It just shows you the aircraft pitch angle. And this is extremely important for instrument flight because the attitude indicator is what we call a control instrument. You can use it to make a control input, and then you can check your performance instruments to ensure that your control input is doing what you wanted it to. This is why the attitude indicator should really be in the center of your cross-check so you can quickly manage your aircraft's performance. For example, if you pitched up to 3 degrees nose high and your aircraft is descending slightly, but you want to maintain level flight, you can pitch up slightly to a 4 degrees nose up attitude, and then you can check what that does for you. It's all a matter of control and then performance. That's why this instrument is so important. In fact, the Air Force calls it a control instrument. We can use it to control the aircraft, and then we can check the other instruments to make sure they're performing the way we want. That's why it's super dumb if this thing's not in the center of your six-pack panel. Now, in case you haven't already noticed, when you bank the airplane, it's the miniature horizon bar that actually moves. The miniature aircraft doesn't bank. It just stays rigid with the aircraft panel. So the horizon just basically stays level with the ground as the aircraft pitches and banks. Keep in mind the miniature aircraft does move up and down, but that's only so it can be adjusted up or down to accommodate pilots of different heights. You can do this by twisting this little knob down here, and you should really be on the ground for this, but you can do it in straight and level flight if you're in a pinch. Now, as we mentioned before, the attitude indicator is also a gyroscopic instrument, just like the heading indicator. Sometimes you'll find attitude indicators that use electricity to spin the gyro inside of these, but that's pretty rare. On most trainers, these typically use suction from the vacuum system to spin the gyro. So because of that, if you're not getting good suction on the vacuum system, your attitude indicator won't work properly. So in this case, it's good to suck. Anyway, have you ever played with one of these as a kid? If you don't know what this is a toy top that you spin, and it maintains its balance by using gyroscopic principles. The faster you spin a top, the more resistant it is to wobbling. As this mass spins around its axis, it becomes resistant to outside forces to the extent that a top is actually able to maintain its balance on this sharp point as it rotates. And as I mentioned in the last video, this is called rigidity in space. And the attitude indicator has a similar gyro inside of it that's spun by air from the vacuum system. Because of this spinning motion, the gyro rotor becomes rigid in space and it wants to maintain its position. Gimbals are then attached to the rotor axis, and this allows the aircraft to move around the stable gyro. The gimbals are then mounted to the inside of the attitude indicator. That way, it can still maintain its position in space. Then it's connected to this horizon reference arm, which is connected to the horizon on your attitude indicator. And as the aircraft rolls and pitches, the horizon line maintains rigidity in space along with the gyro rotor. Now, just like the heading indicator, the attitude indicator has a lot of moving parts inside of it. And because of that, friction can cause it to be less accurate. And this is what we call precession. But unlike the heading indicator, where the pilot has to align the heading with a magnetic compass, we don't have to do anything with the attitude indicator as long as it's working properly, with the exception of setting the miniature aircraft to the correct height. Most older style attitude indicators have something called pendulous vanes. When the aircraft is in straight and level, non-accelerated flight, the vacuum system will periodically reset the horizon line where it needs to be. In fact, there might be times when you go out to the aircraft and the attitude indicator might seem a little jacked up. And when you crank the engine, it might be a little bit slow at resetting back to the horizon. That's fine. These things sometimes need as much as 5 minutes for the gyro inside of them to get stabilized in order to give you the correct bank indications. And when you taxi, as long as the attitude indicator doesn't tilt more than 5 degrees during a turn on the ground, it's safe to assume that the attitude indicator is working properly for IFR flight. If it's showing more than 5 degrees, that's bad, because you shouldn't be banking on the ground, hopefully. Now, something I want to mention about these attitude indicators is that a lot of the older ones have pitch and bank limitations. If you go past these, the horizon can actually tumble on you with the gyro. On most of these, the bank limit is somewhere from 100 to 110 degrees, and the pitch limit is between 60 and 70 degrees. When these limits are exceeded, the horizon line will spin violently around inside of the attitude indicator. And at that point, I pray that you're not in instrument conditions. Yet another reason not to use crazy bank angles in the weather. Okay, now here's some stuff that you probably didn't learn about as a VFR pilot, but as an instrument or commercial pilot, you need to know about this stuff. Gyroscopic attitude indicators aren't perfect. In fact, they're subject to a few errors that you need to know about when you're flying in the weather. Because of inertia, gyroscopic precession can cause some errors in these gyroscopic attitude indicators. Now, I'm not going to go into a bunch of detail on this, but anytime a force is applied to a gyroscope, there's a resultant force that is created 90 degrees ahead of the force applied. This causes our gyroscope to precess to the inside of the turn, and this causes a couple pitch and bank errors that you're going to be expected to know about. The first error you might come across is when you roll out of a turn. When you roll out of a turn, even if it's coordinated, the attitude indicator will often show a slight pitch up and a slight turn in the opposite direction, even if you're actually straight and level. As you can imagine, this can throw you off quite a bit if you aren't watching for it. Now, the worst these errors can get is when you roll out after a 180-degree turn. And once again, when you roll out, this thing will show you that you're pitching up and rolling in the opposite direction for a split second. But don't trust it, this is just a banking error. Keep in mind, if you turn the airplane a full 360 degrees, you're still subject to these errors, but the worst case scenario is when you turn 180 degrees. In fact, this is how they could ask you about this on the written exam. During a normal coordinated turn to the right, a pilot rolls out on a heading 180 degrees from their original heading. The pilot was able to roll out to a straight and level attitude by using visual references. What banking error could the pilot expect to see from their attitude indicator? Okay, which one do you think this is? Well, it's obviously not this one. We know that there is a banking error, and this one is obviously a stupid answer. The correct answer is this one because left is the opposite of the turn when we roll out. What about this question? During a normal coordinated turn to the right, a pilot rolls out on a heading 180 degrees from their original heading. The pilot was able to roll out to a straight and level attitude by using visual references. What error could the pilot expect to see from their attitude indicator? Okay, so once again, this error causes two problems. When we roll out of a coordinated turn, the attitude indicator initially shows us banking in the opposite direction. And it also shows us in a climb. So this one right here is the correct answer because it's the only one that mentions the attitude indicator showing us in a climb. In addition to the regular banking error, the attitude indicator also has something called a skidding error. Anytime you roll out of a skidding turn, the attitude indicator will once again show your aircraft banked in the opposite direction, even if you roll out to straight and level flight. Because of the skid, you won't always get a climb indication, but you'll still get an indication that the aircraft is banked in the opposite direction for a second. So if you happen to be making a skidding turn to the left, when you roll out, the aircraft attitude indicator will show you in a slight right bank when you first roll out. In addition to this, there are two more errors that you need to be aware of. The attitude indicator is also subject to acceleration errors and deceleration errors. Anytime you speed up in your aircraft, the gyro inside of the attitude indicator precesses, and this increase in airspeed can also make your attitude indicator pitch up and show you in a slight climb. And the opposite is true when you decelerate. When you slow the airplane down, the gyro precesses, and this decrease in airspeed can actually cause the attitude indicator to show you that you're descending. Now, here's what's dangerous about this. The somatic gravic illusion, which I've talked about in other videos, causes your body to sense the same thing. Anytime you speed up, it's going to feel like the airplane is climbing. And anytime you slow down, it's going to feel like you're pitching down. So a good instrument pilot knows about these pitch errors in the attitude indicator and keeps them in mind so they don't overcontrol the aircraft while they're flying in the weather. Before we go, I want to show you a couple more things really quick. First, I want you to see how important this instrument is for IFR flight. According to FAR 91205, this instrument must be fully operational in order to operate under instrument flight rules. So if you're taxiing around and this instrument is bumbling on you more than 5 degrees, you're either going to have to cancel the flight or label this thing as in-op and fly VFR. Now, some of you watching this right now might be flying an airplane with digital flight instruments like this one. And that's super cool because these digital flight instruments eliminate most of the errors that you get with the gyroscopic attitude indicator. Not only that, but big primary flight displays or PFDs like this make it super obvious where the sky is and where the ground are because the horizon line goes all the way across the screen. And if you fly one of these, you have no excuses for your bad attitude. Flying just might not be for you if you can't keep the wheels pointed at the brown stuff. These newer systems are super nice because they have something called an attitude and heading reference system inside of them. We also call this an AHRS. Inside of these magical little boxes, they use solid-state lasers to sense the pitch and bank of the airplane. This information is then sent to the primary flight display so it can be used by the pilot to control the aircraft. And yes, they put them in the middle of the screen just for me. And because these instruments use lasers instead of free-spinning gyros, they don't tumble, they don't get turning errors or acceleration errors, and that makes them super nice. That being said, if you don't want to have a heart attack today, don't look at the price of these things because you will literally fall over in your chair if you start shopping around for these things, which makes absolutely no sense since we're trying to make aviation safer, or that's what they tell us anyways. But what do I know? Hey, thanks for joining me today on this IFR ground lesson. If you enjoyed it, be sure to smash that like button and be sure to make your way over to freepilottraining.net to support this channel and show how much you really care about this content. Thanks for watching, and we'll see you.